Welcome back to Before AGI. We're diving deep today into few-shot learning.
Yeah.
It's an AI concept that's, well, it's really changing the game. It's all about teaching AI to learn like we do, like how we can pick up new things with just a couple examples.
It is remarkable. I mean, for so long we thought, AI needed just mountains of data to learn anything really and useful. But few-shot learning showing us that might not always be the case.
Okay, so what does this look like in action? Paint me a picture here.
Okay, well, imagine trying to teach a computer the difference between, let's say, an armadillo and a pangolin.
Okay.
You know, those scaly anteaters you see sometimes?
Oh, yeah.
You could show it thousands of images, right? The way traditional deep learning works.
Right.
Or you could show it just 4.
4 images.
That's the power of few-shot learning.
Wow.
Yeah, there's this great example by AI expert Shuzhen Wang where he demonstrates exactly this. And what's fascinating is, think about how easily you would grasp that difference as a human, right?
Right.
You see a few pictures, you kind of pick up on the key features, the scales, the shape, the way they move.
Yeah.
And boom, you've got it.
And computers are trying to catch on to that.
Exactly. They're starting to learn how to learn, which is the concept of meta-learning. So instead of memorizing specific examples, they're figuring out the underlying principles that connect things.
Oh, interesting.
So it's like, teaching a kid to identify animals using flashcards, right?
Right.
You're not just showing them pictures, you're teaching them to recognize patterns
Right.
and apply that knowledge to new animals they've never seen before.
So it's not just recognizing, it's about understanding then.
It is, and that ability to generalize from just a few examples is what makes few-shot learning so powerful.
Yeah.
It means we can train, potentially, AI systems to do all sorts of things without needing those massive data sets that we've relied on before.
Okay, now I have to ask, how is this different from zero-shot learning?
Okay.
I mean, are they related?
Yeah.
Or are they totally separate?
They're related in that they both deal with learning from limited data.
Okay.
But zero-shot learning it's like the next level.
Okay.
It's about making predictions about things that the AI has never encountered before with 0 examples.
Wait, hold on. How is that even possible?
Yeah.
Are we talking about, like, psychic computers now?
Not quite. It's more about using logic and relationships.
Okay.
Let's say you have an AI that knows a lot about different animals. It understands that lions are large, have manes, and live in the savannah, while penguins are small, have feathers, and live in Antarctica.
Okay.
So it's got a basic understanding of animal characteristics.
Right.
Now, imagine you want it to recognize a zebra, an animal it's never seen before.
Okay.
You could provide information about a zebra, like its stripes, horse-like features, its habitat.
And the AI can use its existing knowledge to deduce that, oh, this new creature is likely a zebra.
So it's like giving it clues, and it pieces them together.
Exactly.
Okay.
But the success of zero-shot learning really depends on the quality of that information, right?
Sure.
So if it's incomplete or inaccurate, then, the predictions might be off.
Makes sense. So if you had to choose between few-shot and zero-shot for a specific task, how would you decide?
I think it boils down to the task itself and the data you have available.
Okay.
If you can give the AI even a small number of labeled examples, few-shot learning can be incredibly effective.
Okay.
It's like giving it, a targeted mini lesson to kind of point it in the right direction. But if you're dealing with something totally new, right, where there's no existing data to work with, zero-shot learning might be the only option.
So it's about picking the right tool for the job.
Yeah. Okay, so we've talked about the theory. But what about the applications? Where are we seeing it make a real difference?
Well, one of the most exciting areas is in fields where data is scarce.
Okay.
Take medical imaging, for example.
Yeah.
Few-shot learning could help diagnose rare diseases.
Interesting.
Where you might only have a handful of confirmed cases to learn from.
So instead of needing, like, thousands of scans.
Yeah, exactly.
You could do it with just a few.
Potentially. Yeah. And that opens up possibilities for earlier and more accurate diagnoses, especially for conditions that are hard to detect with traditional methods.
That's incredible. What other applications are there?
Well, think about, chatbots and virtual assistants.
Sure.
Traditionally, they needed huge amounts of conversational data to understand and respond to us naturally.
Right.
But with few-shot learning, we could teach them new skills or languages much faster.
Okay.
Maybe even personalize their responses with, just a few examples from each user.
Interesting.
Yeah.
That's pretty powerful. And what about robotics? Could it help there, like with robots becoming more adaptable in real-world situations?
Absolutely. Instead of pre-programming them, right? For every possible scenario, we could show them a few demonstrations.
Right.
And let them figure out how to apply those skills to new tasks.
So like a robot learning to assemble furniture by watching you do it a couple times.
Yeah, exactly.
Okay, so let's get a little deeper into the tech here.
Okay.
I've heard a lot about this framework called SetFit. What makes it so special in the world of few-shot learning?
Well, SetFit is it's fascinating because it's simple.
Okay.
It's efficient, and it's really effective.
Okay.
It's able to achieve great results with way less data than traditional models.
Oh,
which is huge in the AI world.
Yeah.
So less data, better results.
That's a pretty compelling combination.
It is.
How does it pull that off?
It's a two-step process. So first, SetFit uses contrastive training to create what are called embeddings. Think of these as concentrated versions of the data, kind of capturing that core meaning in a numerical form.
Okay.
So during this training, SetFit learns to group similar things together and push different things apart in this embedding space.
It's basically recognizing those subtle differences, even with like limited examples.
Exactly. And once it's created, these meaningful embeddings, SetFit moves on to step 2, which is training a classifier.
Okay.
And this is a simple model that learns to read those embeddings and then accurately predict what they represent.
So it's like creating a map with all the landmarks marked.
Yeah.
And then training someone to navigate using that map.
Exactly. Yeah, and what's really cool is that this combination allows SetFit to achieve some, impressive results with a fraction of the data that traditional models would need.
Now, SetFit isn't the only game in town, right?
Right.
What other approaches are you seeing?
One that's particularly intriguing is the technique developed by Navigator. It's an AI research company. And they're using something called Natural Language Inference.
Okay.
NLI.
Natural Language Inference. Okay.
To train their model.
That sounds pretty complex. Break that down for me.
Essentially, they're teaching the model to understand the logical relationships between sentences.
Okay.
So, can you tell if one statement logically follows from another? Do they contradict each other? Or are they completely unrelated?
So they're training the model to be like a logician.
Exactly.
To pick apart the arguments and see how they fit together.
Exactly. And by analyzing those relationships, the model can learn to generalize its understanding and make predictions, even with just a handful of examples.
Wow.
In fact, Navigator has shown remarkable accuracy with just 8 examples per label.
8 examples. Wow, that's really impressive.
Yeah.
I'm seeing a theme here. Few-shot learning is about doing more with less.
Absolutely. It's about efficiency. Adaptability, really pushing the boundaries of what AI can learn with, limited information.
This is already blowing my mind. I think we need to take a quick break and come back for more on this. Stay tuned.
Sounds good. And we were talking about some of the challenges that come with few-shot learning before the break.
Right, like those hurdles that researchers are trying to overcome.
Yeah.
You mentioned hubness, semantic loss, domain shift, and bias.
Yeah, exactly. They're significant hurdles, and researchers are actively trying to tackle them.
So it's like a big puzzle they're trying to solve.
Yeah.
What strategies are they using?
Well, the exciting thing is there isn't one magic solution.
Okay.
It's more like a whole toolkit of approaches that researchers are developing and refining.
Got it.
So for hubness, for example, they're experimenting with techniques like data augmentation and regularization.
Okay, now those sound pretty technical. Can you explain those a bit more?
Sure. Data augmentation is basically about artificially expanding the training data set.
Okay.
So it's like, you take a few photographs and you create variations of them by cropping, rotating, or adjusting the colors.
Okay.
And this helps create a more diverse and representative set of examples for the AI to learn from.
So instead of just a few pictures, the AI gets a whole bunch of slightly different versions.
Exactly.
Got it. That makes sense. What about regularization?
Regularization is a way of preventing the AI from, becoming too fixated on the specific examples it's seen.
Okay.
It encourages the model to focus on the bigger picture, the underlying patterns,
right,
rather than getting bogged down in, the tiny details of each individual data point.
So it's like teaching the AI to see the forest for the trees.
Exactly.
Yeah. Okay.
And then for semantic loss, that issue of losing important information when you compress data into those embeddings, we're seeing a lot of innovation in embedding techniques themselves.
Okay.
Researchers are coming up with clever ways to prioritize preserving the most relevant semantic features.
So they're making sure that the meaning, like the important meaning, isn't lost when you compress the data.
Exactly, yeah.
It's like choosing the right file compression, like for an image instead of for a text file.
Yeah, perfect analogy.
You want to keep the important details.
Okay.
And then for domain shift, that challenge of AI models performing well in training but then struggling in real-world situations.
Right.
Transfer learning is proving to be really valuable.
Okay, transfer learning. Remind me what that is again.
Sure. It's basically about pre-training a model on a large data set from a related field.
Okay.
And then fine-tuning it on a smaller, more specific data set for the target task.
So you give the AI a base understanding first, and then you fine-tune it.
Exactly. Think of it like, learning the basic rules of driving in a simulator.
Okay.
And then practicing on real roads to get used to the nuances of actual traffic.
Okay, that makes sense. You're bridging that gap.
Yeah.
So it sounds like they're tackling these challenges head on, like with a lot of creative approaches. Where do you see this going in the future?
Well, one exciting direction is toward developing models that can learn from a wider variety of tasks. Okay.
So instead of being trained for just one specific problem, these models would be exposed to, a diverse range of challenges, helping them develop more generalized learning abilities.
So it's like training an athlete for multiple sports instead of specializing in just one.
Exactly. Makes them more adaptable and well-rounded.
Right.
Another promising area is combining few-shot learning with other AI techniques like reinforcement learning and generative modeling.
Okay, now those are a couple I need reminders on.
Right, so reinforcement learning is about training AI agents to make decisions in an environment to achieve a goal, like winning a game or navigating a maze.
Okay.
And generative modeling is about teaching AI to create new content, like text, images, or music that resembles the data it's been trained on.
So you're putting together a team of AI specialists, each with their own skill sets, to work together.
Yeah, a great way to think about it.
Okay.
By integrating these different approaches, we can create AI systems that are far more powerful and versatile and capable of learning from limited data.
This is all pretty mind-blowing. But let's step back for a second and think bigger picture. How might few-shot learning change the trajectory of AI development as we get closer to AGI?
That's a big question.
It is.
But one that's worth exploring. One of the hallmarks of human intelligence is our ability to learn new things quickly.
Right.
Adapt to new situations with very little instruction. Traditional deep learning models, with their reliance on massive data sets, haven't been able to replicate that efficiency.
We're pretty good at picking things up on the fly. We don't need a million examples to learn something new.
Exactly. And few-shot learning offers a way to develop AI systems that are more aligned with how we learn as humans.
Okay.
It has the potential to make AI more efficient, adaptable, and ultimately more intelligent.
So we're moving away from AI as this data-hungry beast to AI that can learn more like we do from the world around it.
Precisely. And that shift has profound implications for how we design and develop AI systems in the future. Imagine AI assistants that can learn new skills instantly. Robots that can navigate unfamiliar environments with ease, and personalized medical treatments that adapt to each individual's unique needs.
Wow, those are some game-changing possibilities.
They are.
Sounds like few-shot learning could be a key stepping stone on the path towards more human-like AI.
Yeah.
But I'm also curious about how this is being applied today. Like, what are we seeing right now?
Well, one area where it's making a big difference is in personalized technology. Think about, the way we use apps and devices to tailor our experiences to our individual needs.
Right.
Few-shot learning is making those personalized experiences even more intelligent and intuitive.
So instead of just those generic recommendations, we're getting suggestions and guidance that are truly tailored to us.
Exactly. Imagine a music streaming service that can create a perfect playlist for you based on just a few songs you've liked.
Okay.
Or a fitness tracker that can adjust your workout routine based on your progress and biometrics.
Yeah, that's taking personalization to a whole new level.
It is. And it's not just about consumer-facing applications. Businesses are using few-shot learning to make smarter decisions.
Okay, tell me more about that.
One big area is data analysis.
Okay.
Businesses are generating mountains of data these days.
Right.
But extracting valuable insights from all that information can be a real challenge.
Yeah, I can imagine.
Few-shot learning can help streamline that process, enabling AI systems to quickly identify patterns and trends with much less data than traditional methods require.
So it's like having a superpowered analyst on your team.
Exactly.
Yeah.
This can help businesses understand customer behavior, predict market trends, and make more informed decisions.
Powerful stuff. What other business applications are there?
Another big one is fraud detection.
Okay.
Traditional fraud detection systems are often slow to adapt to new tactics.
Right.
But few-shot learning can enable...
And that's crucial in today's digital world, where things are changing so fast.
Absolutely. It's like giving businesses a proactive defense system that can adapt and evolve.
So few-shot learning is already having a major impact, and its potential for the future is huge. But I imagine there are still challenges ahead.
There certainly are. And those challenges raise some important questions about how we design, implement, and govern these systems to ensure they're used responsibly and ethically.
Those are crucial considerations, and I think we need to delve into those more when we come back for the final part of our deep dive. So we were talking about some of the concerns around responsible and ethical development as few-shot learning gets more powerful.
Yeah, and one concern is misuse. Like any powerful tool, it could be used for things that aren't good.
Like what kinds of things are we talking about here?
Well, imagine someone using it to create AI that can adapt to and exploit vulnerabilities in cybersecurity systems.
Oh, wow, that's a scary thought.
Right. So as these models become more capable, we need to be thinking about safeguards and ethical guidelines.
So like we do for any powerful technology, to make sure it's used responsibly.
Exactly. And then there's job displacement. As few-shot learning allows AI to do tasks that used to need human experts.
All right, like jobs involving repetitive tasks or data analysis could be automated.
Yeah, but I also think it could create new opportunities and help us do things better. Instead of replacing jobs, it could free us from boring tasks.
So we can focus on more creative and strategic work. It's AI working with us, not against us.
Exactly. It's about finding the right balance.
Okay, so beyond the potential risks, there's a philosophical debate too. Some people say few-shot learning is bringing us closer to truly intelligent machines. What do you think?
Well, that's a big question. Few-shot learning is definitely pushing the boundaries. AI can be more adaptable, efficient, even creative.
But are they actually thinking like we do?
That's the real question. Even with few-shot learning, AI is still based on patterns and computation. It doesn't mean it understands the world like we do.
So there's a difference between mimicking intelligence and actually having consciousness.
Exactly. And whether we can bridge that gap is something people will be debating for a long time.
For sure. But even if it doesn't lead to truly intelligent machines, it's already changing things.
Absolutely. I think the key takeaway is this. Few-shot learning isn't just a technical thing. It's a whole new way of thinking about AI and its potential.
We're seeing AI not as this massive data-hungry machine, but as something that can learn more like us.
Exactly. And that could make AI more accessible, personalized, and beneficial for everyone.
Well, it's been an incredible journey exploring this with you. Thanks for sharing your expertise.
My pleasure.
And to our listeners, thanks for joining us on this deep dive into few-shot learning. If you want to keep exploring AI with us, subscribe to the Before AGI podcast. And for a deeper dive into the technical side of things, check out the Ian Ochieng AI YouTube channel. You'll find tons of tutorials and insights there. Until next time, keep learning, keep questioning, and keep pushing the boundaries of what's possible with AI.